Okay, so relations and functions is just one of those sections that people kind of make a bigger deal out of than it needs to be. This is just some vocabulary, some new vocabulary of things you already know. When you hear the word relation, it is just simply another way to say an ordered pair, okay? And all of the x values in the ordered pairs together make up the domain. Domain is another vocabulary word that you're going to hear me talk about. All the word means when I say domain is your x values. Now, of course, if we have a fancy name for the x values, we're going to have a fancy name for the y values too. And that is range. All right? Domain and range. Domain, x values, range, y values. That's all this is. All right, so for this it says find the domain of the relation. Really, all I'm asking you on part A is to tell me the x values. We usually do the fancy squiggly bracket here, and we list the x values in order from least to greatest. So 1, 2, 3, 4, 5, and then close it with a squiggly bracket. Okay, here's the thing too. In your homework, if you were to hit the space bar after the comma, it's going to mark it wrong, even if you have the right numbers. I don't know why this homework does that, but it does. So just do not put a space after the comma. All right, so on part B, it says find the range. Remember, range is a fancy word for the y values. Squiggly bracket, 1, 4, 9, 16, 25. That's it. That's all this is. Okay, so sometimes we use mapping to show a relationship or a relation. Okay, and let me just show you what the mapping looks like. All right, so here's a map. It says that Allison has a birthday on April 25th. Penelope has a birthday on May 23rd. June has a birthday on August 2nd. Gregory has a birthday on September 15th. Jeffrey has a birthday on January 12th. Lauren has a birthday on May 10th. Alice has a birthday on February 3rd. Liz has a birthday on August 2nd. Danny has a birthday on July 24th. Look, Danny and Steven, which I think I missed Steven. Anyways, Steven and Danny have the same birthday. That's okay. People are allowed to have the same birthday. Also, look who else has a shared birthday, June and Liz. So then the question to this says, list the ordered pairs of the relation. Okay, so the ordered pairs would be, and I'm not going to list all of them. I'm not going to waste your time like that. But the ordered pairs, we'll just start it. Allison, April 25th. Then we have Penelope and May 23rd. Okay, and we can keep going. I'll just do June and that's it. June is August 2nd. All right, so you see how you would list the ordered pairs of the relation. Now, part B, again, keep in mind I didn't finish that, all right? So on part B, it says find the domain. The domain is simply every one of these people's names, okay? So on the domain, we would list all the names. So Allison, Penelope, June, and I'm not going to finish, but you get the idea. So on part C, it says find the range. The range, you would simply list all of the birthdays. Now, here's the thing. Notice that July 24th and August 2nd have two lines going to them. You don't have to list July 24th and August 2nd twice. You can list it just once. That's fine. You do not have to list it twice if there is more than one, okay? So, but nonetheless, you would list January 12th, you would list February 3rd, April 25th, and so on. But again, the ones that have 2, you do not have to list them twice. All right, so for this one, this is just another way to do it, another way to write it. Okay, it says, so use the graph of the relation to list the ordered pairs. So the first thing I'm going to do is I'm going to list the ordered pairs. These are kind of hard to see because they're so light. I'm going to color them in with black. Hold on just a second. All right, now they're easier to read. Okay, so the order really doesn't matter, but we could list the ordered pairs. That's what part A wants us to do, which would be for this point right here, that is -3, 4. Then we have -3, -1. That's this one. Then we have 0, 3. Then we have this one, 1, 5. Then we have 2, -2. And then for the last one, we have 4, -2. All right, so then part B says find the domain of the relation. So on part B, the domain is squigglies, and we list only, if it occurs twice, we only have to list it once, remember? So we would list -3, 0, 1, 2, and 4. We do not have to list anything that occurs twice. All right, on part C, they want us to find the range. So again, we don't have to list these two twice. We can just list it one time. So 4, -1, 3, 5, and -2. All right, and the thing is, don't forget whenever you're typing this into your homework, don't put spaces after the comma. It will mark it wrong. Okay, there's a special type of a relationship, and it's called a function, and it does occur quite often in mathematics. And so you will get this question quite often in some of your upper level math classes, and they ask you, is this a function? And then they'll give you something, and it could be a graph, it could be ordered pairs, it could be almost anything, and they will ask you if it's a function. All right, and so I always, whenever I was in school, this definition right here, I don't know why, but it irritated me. It didn't make sense to me, no matter how many times they said it, but here is the gist of it. Okay, so the gist is, your x values are not allowed to repeat if something is a function, okay? So, to be a function, x values are not allowed to repeat, okay? This right here is the exact same thing as this. It took me a while to actually come up with this. Like, it just took me a little bit because I was trying so hard to understand these words that it just didn't click until I came up with this. And it is true, your x values are not allowed to repeat. Now, remember, we have a bunch of fancy words for x values. We've got independent variable, so your independent variables are not allowed to repeat. Your inputs, not allowed to repeat. Your domains, not allowed to repeat in order for something to be a function. So let's go back to the birthday one. So if they say, is this situation right here a function? Look at it this way. Each person is only allowed to have one birthday, okay? So your x values are not allowed to repeat. Allison is not allowed to have 2 birthdays, okay? But over here, people are allowed to share birthdays. That's okay. But each individual person is only allowed to have 1 birthday. So our x values in this case do not repeat, but our birthdays, they do repeat, and that's okay. All right, so let's take a look at this one. It says, determine whether the relation is a function. So take a look at your x values. Do they repeat? Okay. -3, -2, -1, 0, 1, 2, 3. So it is a function. So on part A, letter I, it is a function. Okay, so let's look at double I. Find the domain. The domain of this is -3, -2, -1, 0, 1, 2, 3. Triple I says find the range. 27, 8, 1, 0, and the 1 is repeating, so I don't have to write that. The 8 is repeating, the 27 is repeating, so I don't have to write any of those. Okay, so I am done with this one. All right, let's look at this next one. So on B, is it a function? 9, 4, 1, 0, 1. Oh, our x values repeat. So nope, it is not a function. Double I, we can still find the domain and range even if it's not a function. So we would have 9, 4, 1, 0. I would not list the 1 again. I would not list the 4 again, and I would not list the 9 again. So we're good with what we have here. All right, so part 3, let's look at our range, which is our y values. -3, -2, -1, 0, 1, 2, 3. All right, that's it. That's it for this problem. Again, don't forget, whenever you're doing your homework, don't put spaces after the commas. So let's use mapping to determine on part A whether the relation is a function. So again, these are not allowed to repeat, but look what happens. Lydia has 2 phone numbers. Marty has 2 phone numbers. So it is not a function. Why is it not a function? Because of Lydia and Marty. Okay, on part B, find the domain. The domain in this case is Lydia, Eugene, Janet, Rick, and Marty. On part C, find the range. The range is all of these phone numbers, 321 549 3327. I will not do this to you on a test. You're welcome. 427. Oops, that's a dash, not a decimal. 658 23 2314, and so on. I'm not going to finish writing these phone numbers down. But nonetheless, for the range, you would list every single one of them, as long as they don't repeat. Okay, so function notation. This is something that every time I teach it, I always get students that say, why can't we just keep it wise? Why do we have to use function notation? Well, honestly, now that I've been doing this a while, I actually like function notation better because it's easier to see your input and your output easier. I said easier twice. It's easier to see what your input is and what your output is. And let me show you what I mean by this. But first, let's go over the some definitions here. All right, so for the function y, it is equal to f of x. That's how we say this, f of x. F is the name of the function. X is your domain. What is domain fancy for? X values. F of x is the range value y corresponding to the value of x. F of x is just a fancy way to say y's. So where we used to write y is equal to, let's say, 3x plus 4, now we might see f of x is equal to 3x plus 4. Okay? These two things are the exact same thing. Okay? So you could either have a y there or you could have a f of x, which just stands for a function of x. Okay? All right, so x is your independent variable, y is your dependent variable. Okay, so remember whenever I said easier twice earlier? Okay, so this is kind of what I'm talking about. All right, so for the function f of x is equal to 2x squared plus 3x minus 1, we want to evaluate it at f of 3. I like how this is written better, and I think that once you get used to it, you'll like it better too. It's just a matter of getting used to it. So in part A, we're going to find f of 3. And so that means everywhere I see x, I'm going to put a 3 in. And I just do the math like I did normally. But I keep writing f of 3 on the left-hand side. Okay, and you'll see what I'm talking about here in just a second. So I do this first. 3 squared is 9. 9 times 2 is 18. Then I do 18 plus 9, which is what, 27 minus 1 is 26. So f of 3 is 26. Now, here's the thing that I like about function notation. When you get to your final answer, you see that you put in 3, you got out 26. So you can actually easily and quickly write the ordered pair that goes with it. It's staring right at you, okay? So that's why I really do like function notation better. Let's try it with f of negative 2. So we're going to do this in a different color. F of negative 2 is equal to 2 times negative 2 squared plus 3 times negative 2 minus 1. So I would do this first. Again, keep writing your f of negative 2 on the left-hand side. So I've got positive 4 times 2, which is 8. This is minus 6 minus 1. So 8 minus 6 is 2. 2 minus 1 is 1. So my ordered pair would be my input is negative 2, my output is 1. My x is negative 2, my y is 1. Okay, so we're going to do this last one, but I obviously ran out of room. So if you haven't written this down, you might want to hit pause because I'm about to erase. All right, so now we're going to do f of a. So f of a is simply, I put an a everywhere an x is. Notice I'm not putting parentheses around it. Doesn't matter. It really doesn't. Okay, so it does whenever your input is a negative number. It matters more. Or if it's just a number altogether, because see, if I did 3, it would look silly if I didn't put a parenthesis. Can you really tell that that's 3 squared, or does it look like 23 squared, right? So that's why you have to, whenever you're putting in a number, you have to put the parentheses around it. But when you're putting in a variable, you don't have to. If it's a single variable, if it's a double variable, which we're not really dealing with in this class, or a sum of some variables, then you do. But for the sake of this class, we don't have to if it's a variable. All right, so let's look at Sylvia's emails. So the number of unread emails in Sylvia's account is 75. This number grows by 10 unread emails a day. The function n of t, that's how you would pronounce that, n of t is equal to 75 plus 10t, represents the relation between the number of emails, n, so n is our number of emails, and time, t measured in days. Determine the independent and dependent variables. So our independent variable is the variable that you don't really have any control over, right? So usually time is the thing that you don't have control over. I say usually because there's a rare occasion whenever it's not your independent variable, but 9 times out of 10, if one of your variables is time, then that will be your independent. So in this case, our independent variable is days, which is, what is our days measured in? T, okay? So that's what they use T for, T measured in days. Our dependent variable is the other variable. So in this case, it's the number of emails, which what variable describes that? N. Okay, so that's what they're looking for here. N and T. Then on part B, oh, oops. I got a little ahead of myself on that. That was still part A. All right, so then on part B, find N of 5. So we're going to put 5 in where we see T. So N of 5 is equal to 75 plus 10 times 5. So N of 5 is equal to 75 plus 50. N of 5 is equal to 125. So what does this mean in this case? After 5 days, her number of unread emails is 125. So you would write that as a sentence. After 5 days, the number of unread, I can write, I swear, emails is 125. All right, I hope that makes sense. Okay, so the one thing that this textbook didn't really do a very good job of that I am actually going to teach you now is something called the vertical line test. Okay, the vertical line test is something that if you were to place a vertical line anywhere on the graph, will it touch the graph in more than one spot? So what that means is, do your x values repeat? So we're at this point still looking to see if something is a function. Hang on, sorry about that. All right, so it says here, use the vertical line test to determine if something is a function. If a vertical line touches more than one spot on a graph, it is not a function. So notice there's a vertical line here, it only touches one spot on the graph. There's a vertical line right here, it only touches one spot on the graph. Vertical line here, it only touches one spot, and so on. But look at this one over here. If I put a vertical line right on the y-axis, look how many places it touches. It touches there, it touches there, it touches there. That means your x values repeat, in this case, 3 times. Okay, so that means that this one is not a function. This one is a function. Okay, not a function on the right, is a function on the left. So we would say this one passes the vertical line test, and this one fails the vertical line test. All right, so for this problem, let's write the domain and range, and we're going to write this as an inequality, okay? So remember, what is domain? Domain are your x values, okay? And so we're looking at our x values. Our leftmost x value is right here, okay? I'm going to erase that. But it's right here, okay? So it's at -5. Our leftmost x value is right here, and it's at -5. One thing I want you to notice is that this is an open circle right there. So that means we do not include that x value. So I will not put an equal symbol underneath that inequality symbol. Okay? Now, look at our rightmost x value. It's right here at -1. And so it is a closed circle, so I would put an equal to symbol under that. So this is how I would write the domain of this graph right here. Okay, so I looked at my x, my left x value goes right here, my right x value goes right here. If it's a closed circle, it has an equal to symbol underneath. If it's an open circle, it does not have the equal to symbol. Notice the x is in the middle. And I say, this is how you read this compound inequality. X is greater than -5 and less than or equal to -1. You read it from the inside out. X is greater than -5 and less than or equal to -1. Now, let's find our range. I'll do range in a different color. All right, so look. What's the fancy word for our range? It's our y values, right? So we're going to do the exact same thing, only this time we're looking vertically, okay? What is our lowest point? Our lowest point is down here at -5. Our highest point is up here at, oh, not there. I want to do that every time, but it's not. Even though this is our rightmost point, it's not our highest. Our highest is actually right here, okay? So our highest is at 4. Now we need to decide if we use open or closed. Well, in this case, this doesn't have a dot, but it is included, right? So it would be less than or equal to the 4, and it would be greater than, but don't include this because it's an open circle. So it would be just like that. All right, that's it for this section. If you have any questions, don't hesitate to ask.